They aimed the most powerful telescope humanity has ever built at a place that appeared to contain absolutely nothing. No galaxies. Just a stretch of silent black. At the time, that conclusion felt reasonable. If light wasn't obvious, there was nothing there to study. Then the James Webb Space Telescope looked again. It didn't glance. It didn't rush. It stared. For days, Webb collected the weakest signals imaginable, photons that had been traveling for billions of years, stretched thin by the expansion of space itself, barely surviving the journey. Hour after hour, the image deepened. What once seemed empty began to reveal structure. What looked like absence began to show form. When the final image emerged, it didn't simply improve our view. It overturned it. Where earlier instruments detected almost nothing, Webb revealed a staggering density of galaxies, tens of thousands packed into a region of sky smaller than a grain of sand held at arm's length. Entire galaxies, each containing billions of stars, had been hiding in what once looked like total darkness. This wasn't just a sharper picture. It was a correction. For most of human history, we were not seeing the universe as it truly is. We were only seeing what our tools allowed us to see. The cosmos was never quiet, never sparse, never empty. Our blindness created the illusion. Astronomers once tried to understand the universe by counting what was visible and extending those numbers outward. The logic felt sound. Observe what you can. Measure density. Scale it up. But the flaw was enormous. It was like estimating the population of an entire city by standing on a single street in the middle of the night. Hubble revolutionized astronomy, but it could only see visible light. The oldest light in the universe no longer exists in that form. As space expands, ancient light is stretched into infrared wavelengths, completely invisible to earlier telescopes. Those galaxies were never missing. They were never gone. They were simply hidden. When Webb arrived with infrared vision, the universe didn't change. Our perception did. Darkness collapsed into abundance. Emptiness revealed itself as illusion. Scientists deliberately aimed Webb at regions Hubble had already examined and instructed it to observe patiently, without assumptions, without shortcuts. What came back was overwhelming. A dense population of galaxies, many containing hundreds of billions of stars. Around countless stars, planets almost certainly formed. And on some of those worlds, the conditions for life may have arisen. All of it concealed in a place once dismissed as nothing. The implication was unsettling. If we were this wrong about such a tiny patch of sky, then our estimates of the entire universe are almost certainly incomplete. The true number of galaxies may be far larger than we ever imagined, so large that the numbers stop feeling real. And then Webb uncovered something even more disturbing. It found massive, organized galaxies appearing astonishingly early in cosmic history, far sooner than existing theories predicted. According to established models, there shouldn't have been enough time for such structures to form. At first, scientists assumed something was wrong. Instruments were recalibrated. Data was checked again and again. The results didn't change. These galaxies were real, and they weren't rare. The early universe wasn't slow or gentle. It was explosive. Stars ignited at extreme rates. Galaxies assembled rapidly. Structure didn't patiently evolve. It erupted into existence. This discovery forced a deeper reckoning. Although the universe is about 13.8 billion years old, the region we can observe extends far beyond that number. This isn't a contradiction, it's a consequence of expansion. Space itself is stretching, carrying galaxies farther apart over time. Because of this, the observable universe now spans roughly 46 billion light-years in every direction. Light that began its journey shortly after the Big Bang has been traveling toward us ever since, while the space beneath it continued to grow. The destination kept moving as the light was already on its way. Some galaxies are now receding from us faster than the speed of light, not because they violate physics, but because expansion itself has no speed limit. Relativity restricts motion through space, not the growth of space. This creates a boundary, a cosmic horizon. Beyond it lies reality that can never be seen or measured. Entire regions of the universe exist forever beyond our reach. No signal from those places will ever arrive here, no matter how advanced our technology becomes. And that boundary is not static. With every passing moment, more galaxies cross it. Their light reaches us now, but no future signal ever will. They aren't destroyed. They are simply cut off. The James Webb Space Telescope didn't just reveal more of the universe. It revealed that the universe is slowly disappearing from us. Cosmic expansion is accelerating, driven by a mysterious force called dark energy. This acceleration makes the loss permanent. Galaxies visible today are already on borrowed time. Each observer exists within their own observable bubble, a region defined by distance, time, and causality. Everything inside that bubble is knowable in principle. Everything outside it is not just unknown, but unknowable.